How can we approach an equation in which a radical appears? Well, those roots are functions. They're one-to-one functions, and they have power functions as their inverse. So we can approach a variable inside a radical as we do any other variable inside a function. Isolate the radical, then rewrite the equation in terms of the inverse, in this case in terms of the power function, and finally finish solving if the variable isn't alone inside the radical. So as our simplest example, we have the equation square root of x equals 5. Remember, if there isn't an index, the index is invisibly 2. The equation square root of x equals 5 means the same thing as x equals 5 squared. And then we just work out 5 squared, x equals 25. And that's our solution to this equation. It only has 1 because the radical function is 1-to-1. We can check the square root of 25 really is 5. In this next example, we have the fourth root of x, but that's not by itself. That's not isolated. So first we need to isolate that. We'll add 3 to both sides, and now we have 2 times the fourth root of x equals 1 plus 3 is 4. Then we'll divide both sides by 2, and we'll have the fourth root of x is 4 divided by 2 is 2. So the fourth root of x is 2. Rewriting that in terms of the power function, x is 2 to the power 4. And then working out 2 to the power 4, either by hand or on a calculator, we can count out 2, 4, 8, 16, or we could work that out on a calculator. That's our solution. Again, we can plug in to check. 2 times the fourth root of 16 minus 3 is 2 times 2 minus 3. So that's 4 minus 3, which is indeed 1. In our next example, we have the third root of 3x minus 1 is negative 4. Now we might be a little bit concerned about that negative sign, but this is an odd root, so there are no problems here. The third root of 3x minus 1 is negative 4. Notice that the radical is the only thing on this side of the equation. Everything happening on the left side of the equation is inside that radical. So there's nothing we need to do to isolate that. We can immediately rewrite this as 3x minus 1 is negative 4 to the third power. So 3x minus 1 is working out negative 4 to the third power. We get negative 64. Add 1 to both sides. 3x is negative 63. Finally, divide both sides by 3, and we get x is negative 21. That's our solution, single solution to this equation. To check, we'll say what is the third root of 3 times negative 21 minus 1? That's the third root of negative 63 minus 1. So the third root of negative 64, which is indeed negative 4. 2 times the square root of x plus 7 minus 4 is 8. So our square root of x plus 7 is not currently alone on the left side of the equation. First, we need to isolate it. We'll add 4 to both sides, which leaves us with 2 root x plus 7 equals 8 plus 4 is 12. We'll divide both sides by 2. Root x plus 7 equals 6. And now our square root is alone on the left side of the equation. Rewriting this in terms of a power function, x plus 7 is going to be 6 to the second power. In other words, x plus 7 is 36. And now to finish solving, we subtract 7 on both sides. X is 29. To check, we'll say 2 times the square root of 29 plus 7, all minus 4. That's 2 times the square root of 36, all minus 4. That's 2 times 6 minus 4. 12 minus 4 really is 8. So in order to solve an equation in which we have one radical appearing, one square root, we isolate the root, we rewrite in terms of a power function, and then we solve from there.